Hey guys, so in the last lesson we talked about how we can determine the shapes of different molecules. Today we're going to be applying that knowledge to determine whether or not molecules are polar. So when we're talking about polarity, you need to know what it is and why it happens. You also have to be able to predict whether a molecule is polar or non-polar, given nothing but its name or formula, which means that you first have to be able to draw that molecule and then based on the drawing and its shape, determine whether the molecule is polar or not. You also need to know the difference between bond polarity and molecular polarity. You have to know how we represent polar molecules in diagrams. You also have to know the relationship between solubility and polarity, and what it means when we say bonding is a continuum. So polarity happens when there is an unequal sharing of electrons in a bond between two covalently bonded atoms. So anytime you have a covalent bond and the two atoms that are covalently bonded are different elements, one of them is always going to have a higher electronegativity than the other. And the one with the higher electronegativity will have a stronger pull on the electrons in that bond, meaning that you're going to have an unequal sharing of those electrons. Whichever atom has the higher electronegativity is going to end up slightly negative, and the atom with the lower electronegativity is going to end up slightly positive. The bigger the difference in the electronegativities between those two atoms, the more polar that bond is going to be. Polar molecules are any molecules that experience polarity, so where one end of the molecule is slightly positive and the other end is slightly negative. And this will happen anytime you have non-symmetrical molecules. Only molecules that are symmetrical can be polar. You have to take the molecular geometry into account, so you have to know its shape, and yeah, you have to have like the atoms around the central atom need to be the same as each other. A dipole is just a term used to describe a polar molecule. When you have that one end or pole that is slightly positive and the other one that's slightly negative, then you're essentially saying that your molecule has two poles of different charges, and that's where the name dipole comes from. So dipole is just a molecule that is polar. There are two different types of polarity. There is bond polarity or molecular polarity. Bond polarity is, again, anytime you have two different atoms sharing a covalent bond. If those atoms are different elements, then you will have bond polarity. One of those atoms is going to have a higher electronegativity than the other. So the only time you don't have bond polarity is when the two atoms that are bonded to each other are the same element, like a nitrogen bonded to another nitrogen or something. Molecular polarity, on the other hand, has to be the entire molecule is polar. So one end is slightly positive, one end is slightly negative. And you can have a molecule that has bond polarities, but that does not have molecular polarity. And that happens if the bond polarities cancel out. And I'll show you what that looks like in a minute. So yeah, you can have bond polarity and molecular polarity, or you might just have molecular polarity. Or sorry, you might have just bond polarity. Anyway, we'll go through that with some examples. So a molecule can have both types, neither type, or just bond polarity. You cannot have just molecular polarity. Yeah. Okay, so these are examples of the different type of polarity. The only time you will have no polarity at all, so not bond polarity or molecular polarity, is if the molecules that are attached to each other are the same element. So like a chlorine attached to a chlorine or an oxygen attached to an oxygen. This example should be the one underneath it. Ignore this chlorine bonded to a fluorine. This over here is a good example. If you have a central atom and everything that's bonded to the central atom is the same and there's no unpaired electrons, then you will have bond polarity only. You will have both types of polarity if your central atom has unbonded electrons, like with this oxygen here, or if your central atom is bonded to more than one type of element. So in this first example, we have a central atom bonded to a hydrogen and nitrogen. So the central atom is bonded to more than one type of element, so it's going to be polar. In the second example, the oxygen is our central atom, and it's bonded to two hydrogens, so it's bonded to all the same thing, but it has these extra unbonded electrons. That makes it polar. And if you don't have a central atom, like this chlorine bonded to a fluorine, that would have both. It would have molecular polarity and bond polarity. I am at the end of this, by the way, going to go over some more examples. So polarity and solubility. Polar substances will be polar. Polar substances will dissolve in other polar substances. We usually say that like dissolves like. So since water is polar, any polar substance will dissolve in water. Non-polar substances will only dissolve in other non-polar substances. So non-polar things will not dissolve in water. When we draw polarity, we start off by just drawing our normal stereochemical formula. So we just kind of draw it out with the lines for bonds and stuff like that. Then you have to determine the electronegativity of your different atoms. Remember, the closer to fluorine something that's on the periodic table, the higher its electronegativity. And then you're just going to draw the direction that the electrons would be pulled in each bond using an arrow. And then based on that, put in your slightly positive and slightly negative signs to determine if the overall molecule is polar. By the way, when I say, is this molecule polar, I'm asking you, does it have molecular polarity, not does it have bond polarity? So if I specifically say bond polarity, then obviously tell me about that. But if I just say, is this molecule polar, I mean molecular polarity. And I'm going to go over some examples of that once we're done this too. I'll switch over to my document cam. Okay, the last thing, bonding is sometimes referred to as a continuum. On one end of the continuum, we have non-polar covalent bonds. So any molecules that are non-polar would be at one end of the continuum. Kind of in the middle, where we have slightly positive and slightly negative ends, are our polar covalent substances. And then at the other end of the continuum, we have ions that are fully positive and fully negative bonding to each other. That's our ionic bond, obviously. Okay. So it's a continuum because we go from completely neutral, which is our non-polar covalent bonds, to our completely charged, which is our ionic bonds. And then in the middle, we have our polar covalent bonds that have slightly positive and slightly negative ends. And there is like a range of how slightly positive and how slightly negative, depending on the electronegativity of the atoms involved. Okay, let's switch over to my document cam and do some examples here. Okay, so let's start by just doing some examples where we figure out if our molecules are polar or not. So let's say I have ammonia. First of all, you need to know, oh, let me change. There we go. First of all, you would need to know that ammonia is NH3. Then you would need to be able to draw NH3. So I would have my N, my 3 hydrogens, sausage to make sure all the lone electrons end up in a bond, and I would end up with a molecule that looks like this. Okay. The shape of this is trigonal pyramidal because these unbonded electrons are pushing these bonds down into like a pyramid shape. And if you wanted to figure out if this was polar or not, all you would have to do is say, anytime my central atom has unbonded electrons, it is going to be polar. So this would definitely be polar because of those unbonded electrons. Okay? if I wanted to draw this out, if I said draw the polarity of this molecule, I'm just going to redraw it for a second here. So I would again just start by drawing it. I would then look on my periodic table and see that nitrogen is closer to fluorine than hydrogen is. That means nitrogen has a higher electronegativity. So within each of these bonds, the electrons would be getting pulled towards the nitrogen. And so I would represent that with arrows beside each bond. And then because the nitrogen is kind of hogging all of these electrons, the nitrogen would become slightly negative and all of the hydrogens would become slightly positive. Okay, so this is what it would need to look like if I asked you to draw the polarity of this. Okay, let's try another example here. What about methane? So methane, that's another molecule that you need to know the name of. It is CH4. And by the way, you guys don't have to start by drawing the sausage. If you can just like go right to this in your head, that's great. I usually wouldn't bother drawing out the sausage diagram, but for those of you that need to do that to get to the shape, I'm just kind of showing that. So with methane, carbon has 4 bonding sites, so it'll go in the middle. And our hydrogens each have 1 bonding site, so I'll put them around the outside. And then sausage, all of our lone electrons. I end up with something that looks like that. If I were to draw it out, it would look something like that. So the shape of this is tetrahedral. I know that because my central atom has 4 things bonded to it and no unpaired electrons. And because my central atom has no unpaired electrons and all of the things around the outside are the same, this is going to be non-polar. Again, I know that because I have same outside atoms, I have hydrogen all around, and I have no unbonded electrons. Okay, that is how I know that this is non-polar. If I were to draw out the polarity of this, again, carbon is closer to fluorine than hydrogen is. So my electrons would all be getting pulled towards the carbon. That means that all of my hydrogens would be slightly positive, and I would have a slightly negative carbon in the middle. Now, because the ends of my molecule are all the same charge, they're all positive, again, that's showing that this is a non-polar molecule. I'm going to do like 2 more examples just to kind of drive this home. So next up, I'm going to do SF6. So my S has 2 bonding sites. It's going to go in the middle because my fluorine with its 7 valence electrons only have 1 bonding site. So I just need to draw in all 6 of my fluorines. Again, you can most certainly skip this step if you can just go right to drawing the diagram. 1, 2, 3, 4, 5, 6. Okay, and then I'm going to start by sausaging my lone electrons on the sulfur. Then I'm going to realize I still have 4 more fluorines that I need to bond to this thing. So I'm going to start by separating these 2 electrons here and bonding them to the lone electrons on the fluorine. And then I still need more. If this was SF4, I would be done, but it's SF6. So I need to split up these 2 electrons as well to bond them to the lone electrons on the fluorine. And I end up with a shape that looks like this. Again, we don't have to draw in our unbonded electrons around the outside atoms, only if we had some on that central atom. Okay, and now in this case, first of all, this is an octahedral because my central atom is attached to 6 other things and there are no unbonded pairs of electrons. And then I also know that this is non-polar. And again, I know that because my central atom has no unbonded electrons. So the sulfur has no unbonded electrons, and all the outside atoms are the same. Because it fits both of those points, I know this is non-polar. If I were to change one of these from an F to like an H or anything else, this would be polar. Okay, so all of these things around the outside need to be the same, and I can't have any unbonded electrons around that central atom in order for it to be nonpolar. If I were to draw this, fluorine is obviously closer to fluorine than sulfur is, so it would be pulling the electrons away from the sulfur, which means that every fluorine is slightly negative, and my sulfur is slightly positive. But again, the poles are always the same. Oh, I forgot to write that one in. The poles are always the same. They're always negative on opposite sides, which means it's nonpolar. Okay, last example. OCl4. So I've got my oxygen. It has 2 bonding sites. My chlorine only has 1 bonding site. So the chlorine goes around the outside. Then I'm going to make sure that my lone electrons on my oxygen get bonded to lone electrons on the chlorine. And then I still have 2 more chlorine that need to get bonded to this. I'm going to pick either this pair of electrons or this pair of electrons and separate them to bond to the lone electrons on my chlorine. And I end up drawing this. It should look like so. This shape is a seesaw. Anytime we have 4 things bonded to the central atom and some unpaired electrons, the unpaired electrons turn this from what would be a tetrahedral into a seesaw. And this is going to be polar because my central atom has unbonded electrons. These guys right here are going to make this thing polar. Okay? Okay, so let me know if you have any other questions about this. I will say that the trickiest one, which we didn't actually do an example of, but I'll draw it out kind of really quick here in the middle. The trickiest ones are our bent shapes. So if you had, let's say SCl2, where you have a sulfur bonded to 2 chlorines. Some people would draw it like this, which is wrong, unfortunately. You have to draw it where you show that this is a bent shape. If you draw it straight like this, it can look as if this would be nonpolar, though these unbonded electrons tell you that it is going to be polar. But you do need to show me that you know that anytime you have unbonded electrons around the central atom, it cannot be linear. Those unbonded electrons are going to push the bonds out of a straight line. Okay, so make sure, just like when we draw water, like there's space here, when we draw water, you should be drawing it like this, like it's bent, as opposed to in a straight line. That's wrong. So anytime you have unbonded electrons, you need to bend your shape. okay? That's really the only thing to watch out for. Other than that, let me know if you have any questions about this stuff.